Okay, problem 8. In how many ways can we write 10 to the 6 as product of three numbers? The order matters. So let's consider the prime factorization of this number. So we know 10 is 2 times 5. So 10 to 6 is basically 2 to the 6 times 2 to 5. Okay, sorry, 5 to 6. Okay, now we want to write this as a product of three numbers. So basically, let's write this way, A times B times C. Okay, how many ways can we write this? Because 10 to 6 has only two prime factors, 2 and 5. So for numbers A, B, and C, they only have factor 2 and 5, or maybe just one of 2 and 5. So we can write A, B, C in the following way. A has to be 2 to some power, say x1, times 5 to some power y1. x1, y1 are integers. Times B is also of the same form, x2, 5, y2. And C is also 2 to some integer, let's say x3 times 5 to y3. Okay, that's the only way, right? They only have two, at most two prime factors. And in order to have this equation, we must have x1 plus x2 plus x3 equals 6. And also y1 plus y2 plus y3 equals 6. So the question is reduced to find how many ways can we find these integers, x1, x2, x3, y1, y2, y3. And here, these integers are non-negative integers, right? It could be 0, could be 1, could be at most 6, right? We have standard method to solve such number of solutions. So they are basically equal. Let's just consider x. So here, our requirement is that x1, x2, x3 integers larger equal to 0. Okay, so basically we can consider z1 to be x1 plus 1, z2 to be x2 plus 1, z3 to be x3 plus 1. So z1 plus z2 plus z3 equals 9. And here we just require z are positive integers. Large equal to 1. I just add 1 to make it positive. So these two are equivalent, right? These two are equivalent. These two are equivalent. So find the number of solutions for x is equivalent to find the number of solutions for z, right? So this is equivalent to the following question. So we have 9, totally 9. So basically we just draw 9 balls, say 9 balls. And we divide this into three groups, And we have this, we have 8 gaps. So we want to insert this, this ball to separate this into 3 groups. So basically I just choose two positions. And I can separate this into 3 groups. So the total number of solutions of z1, z2, z3 is, we choose 2 positions from these 8 gaps, right? That's the answer. This equals 28. This equals 28. So that means there are 28 solutions for x, or same, we have 28 solutions for y. Right? They are equivalent. So we just consider the weight of this, the number of this ABC, that's just 28 squared, because we can consider this as 2-step procedure. Each step we choose this x1, x2, 3, and y1, y2, y3. So the answer is 28 times 28, which is 784. Okay, that's the answer. Thank you. Okay, we are now at problem 9, geometry. We have ABC as it's an equilateral triangle, and E is a point on AC, extend BE to D so that BDC is 60 degree. BDC, this is 60 degree, okay? Okay, because BAC is 60 degree, BDC is 60 degree, so it's very natural to know that these 4 points are on the same circle, okay? That's cyclic quadrilateral. So we can basically draw this circle. They're basically on this circle, okay? On this circle. Now we see that ADB is also 60 degree because ADB equals angle ACB. So let me mark here. This is also 60 degree. From problem, we know that AD is 3, okay? AD is 3. And the BD is 8. BD is 8. But we don't know the side length of the equilateral triangle. So let's calculate the side length of equilateral triangle. For example, let me denote by A. The side length of equilateral triangle is A. We can consider the angle ADB. We use the law of cosine. To angle ADB, which is 60 degree, right? So we know that cosine angle ADB is equal to AD square plus BD square minus AB square divided by twice AD times BD. And of course, this equals, this is cosine 60, so this equals 1/2. This equals 1/2. And now let's plug in these notations. We have this equals AD is 3, so 3 square. BD is 8, so 8 square minus AB, so minus 8 square. Divided by twice, AD is 3, BD is 8. From here, we can solve A. Okay, we can solve A. We can solve A equals 7. That's the side length. Okay, this equals 1/2, right? So once we get A equals 7, we can solve the length CD. Again, we can use law of cosine to angle say ADC. Okay, law of cosine to angle ADC. We know angle ADC is 60 plus 60, 120. 120. So cosine angle ADC, this is cosine of 120 is minus 1/2. So this equals AD square plus CD square minus AC square divided by twice AD times CD. So let me assume this CD is X, okay? This X, we want to solve X. Okay, let's solve X. So this equals AD is 3 square, CD is X square. AC is, we already solved AC. AC is the side length of equilateral triangle, which is 7 square, divided by twice times 3 times X. This equals negative 1/2. And from here, we can solve a quadratic equation and get X. Let me continue here. The quadratic equation is as follows. We have X squared plus 3X minus 40 equals 0. This is a quadratic equation. And now we have, we can factor this equation. So X minus 5, X plus 8 equals 0. And then we get, because x must be positive, so x equals 5. So the answer is 5. CD equals 5. All right? Okay, this is by law of cosine. Okay, let me tell you another approach, slightly different to solve CD. So let me call this method 1. Method 2. We still use law of cosine to find the side length equals 7. And then to find the length of CD, we can have another approach. This is based on a theorem called the Ptolemy theorem. It means that because A, B, C, D are cyclic, they are on the same circle, we have the Ptolemy theorem. That means AD times BC plus AB times CD equals the product of the diagonal lines, which is AC times BD. So here we have AD times BC is 3 times 7, BC is 7, plus AB is also 7 times CD. CD is something we want to solve. Let me divide by X equals AC times BD. AC is 7 times BD. BD is 8. That's given. So here we don't need to solve quadratic equation. We just solve linear equation to get X. X equals 56 minus 21 divided by 7, which is 5. We also get 5. So we have two approaches to solve CD, but both of them depend on law of cosine in the first step. Okay, that's the solution. Okay, let's move to problem 10. It's a coordinate geometry problem. So let's draw the coordinate system. It's X, Y, and I want, okay, let me draw this unit circle. Okay, and we have a straight line. The straight line is 3x plus 4y. Okay, so I think I should correct this in my note. It's 4y. Okay, 3x plus 4y equals 20. So 3x plus 4y equals 20. This is equivalent to x over 20 over 3 plus y over 5 equals 1. And these two numbers give us the intercepts. Okay, the number under x is the x-intercept. So it's here, 20 over 3. And the number under y is the y-intercept. So 5, the straight line. Okay, maybe let me use blue color. Okay, this is a straight line. All right, we want to find the largest distance from the point on the circle to the line. Okay, so it's easy to see that. Okay, formally, if the largest distance if we draw the line passing through the origin and the perpendicular to the straight line, this line this line intersects the circle on the farthest point. This point has the largest distance to the line. So we need to calculate this length. And on the other hand, this distance is just the distance from the origin to the line plus the radius, So basically we can calculate this distance and the plus 1. Okay, so it's basically solving a right triangle. So let me do it here. We have this right triangle. The side lines here is 5, and here is 20 over 3. And this is basically 5 is 15 over 3, right? So this is like a 3, 4, 5, this Pythagorean triple. This is 3 times 5, this is 4 times 5. So the hypotenuse is just 25, 25 over 3. This is 25 over 3. And then we can calculate the altitude on the hypotenuse. Let's calculate the altitude here. Because the area of the triangle is 1/2 times 5 times 20 over 3. This is also equal to 1/2 times 25 over 3 times h, right? We just use different base and different height. So from here we can solve h. H is 5 times 20 over 3 divided by the hypotenuse, 25 divided by 3. This gives us 4. Okay, this gives us 4. So h equals 4. And then the farthest distance is just h plus 1. H plus 1. 1 is the radius. Okay. So this is a 4, but we want to solve this distance, right? We want to solve this distance, which is 4 plus 1, which is 5. So the answer is 5. Okay, that's the answer. Now let's do problem 11. Arrange all numbers that do not contain these 4 digits, 0, 3, 5, 8, in the increasing order. What's the 1000th number in the list? So let's consider all digits. Let me list all digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we have totally 10 digits. And here we cannot use these 4 digits. Let me cross this 4. 0, 3, 5, and 8. So we have 6 digits to use, right? We have 6 digits to use. Okay, we can basically arrange this in order. So 1 is the first number. Let me use this notation. Okay, 2 is the second number. Let me use this notation. 4 is the third number. 6 is the fourth number. And 7 is the fifth number. 9 is the sixth number. So we use these 6 digits to, okay, we arrange these 6 digits in increasing order. And what's the 1000th number? Okay, basically this is like a base 6 expression. This is similar to number in base 6. Numbers in base 6. So we want to express 1000 in base 6. Okay, so 1000 can be expressed as follows. The highest power that's less than 1000 is 6 cubed. And 1000 divided by 6 cubed, we get the quotient equals 4. So it's 4 times 6 cubed. That's the leading term. And then when we subtract this and divide by 6 square, we have quotient 3. So 3 times 6 square. And then when we subtract these numbers and divide by 6, we get 4 times, we get 4, okay? 4 times 6 to the first power. And finally, we have 4. That's the unit digit. Or you can write this way, 6 to 0 digit. So if we express 1000 in base 6, so 1000 is base 10, right? If we write in base 6, this is like a 4, 3, 4, 4 in base 6. Okay. Now we are using these 6 digits. So in base 6, that basically means 4, the leading term, is the 4th. Okay, if we order this digit, that's the 4th number. So here the 4th number is 6. Okay, okay, maybe let me write this first. This corresponds to 4, 3, 4, 4 in this sequence, And that corresponds to 4 corresponds to 6, right? Circle 4 corresponds to number 6. Circle 3 corresponds to number 4. And circle 4 again corresponds to 6. Circle 4 corresponds to 6. So the 1000th number in this sequence is just 6, 4, 6, 6. The answer is E. Okay. All right, let's come to problem 12, geometry. So we have 3 circles tangent to each other externally, and also tangent to these 2 parallel lines, MN. So we know the radius of the small circles. We want to find the radius for the largest circle. Right, let's see the relation. So here I draw a slightly larger picture so I can draw clearly. So here the idea is as follows. Let me connect C1 to this. Let me draw a diameter perpendicular to these 2 lines. Okay. And also we can connect those centers. Okay. Now I'd like to also draw these lines. This radius is 4, and this radius is 9. So we can assume the radius for the largest circle is x. So this becomes x. This becomes x. So the distance between these 2 parallel lines is just 2x. Right. Now let me also draw this. I draw this horizontal line. Horizontal line. Let me call this intersection to be x. And I extend this here. Let me call this y. And this center is basically C2, okay, C2. And I can do, this is like x, y, z. Let me see, z. So x, y, C2, z is a rectangle. It's a rectangle. Okay. So let me call this AB. AB is perpendicular to these 2 parallel lines. All right. The radius of the largest circle is x. We can see that XC1 is x minus 4, okay? Because AX equals 4. AX equals the radius of C3 equals 4. And also X, okay, ZB equals the radius of C2, which is 9. This is 9. So we have C1x equals x minus 4, and the C1z equals x minus 9. Okay. And the C1, C3, this equals x plus 4, right? X plus 4. This is x, this is 4. And C3, C2, this is 4, this is 9. So C3, C2, this distance is 13. And the C1, C2 is x plus 9. Okay, let's find the following. We have a following relation. X, C3 plus C3, y. This is like the length of the rectangle. This is basically xy. Xy also equals ZC2. Okay, ZC2, they are both the length. Now let's express this distance by x. XC3 equals, okay, XC3 can be regarded as a side length of a right triangle, XC1, C3. So by Pythagorean theorem, this equals x plus 4 square minus, okay, let me write more details. This equals C1, C3 square minus C1x square, and then we take square root, right? So this equals x plus 4 square minus C1 x is like x minus 4 square. Also, we have C3y. C3y is equal to C3 C2 square minus C2y square. So C3 C2 square is 13, right? 13 square minus C2y. Okay, what is C2y? Because the distance between these two parallel lines, okay, this is L. This is L, okay. The distance between these two parallel lines is 2x. And so this part becomes 2x minus 13. Okay, minus these two radius. So it's 2x minus 13 square. That's the expression of C3y. Now let's come to ZC2. ZC2, okay, we consider another right triangle. This corresponds to C1 C2 square minus C1 Z square. Okay? So this is x plus 9 square minus x minus 9 square. Okay. Now let's set up this equation. We have, let me do some calculation in the square. So here, if you calculate, you see this equals, we cancel the square terms. This is basically 16x. And this equals 52x minus 4x squared. And this equals 36x square root. Now we can set up the equation. So 16x square root is just like 4 square root x plus 52x minus 4x squared. This equals 6 square root of x. From here, we can solve x. So basically, we can combine these two terms. We have 52x minus 4x squared equals 2 square root of x. And then we can divide by 2 on both sides. So on the left-hand side, it's equivalent to dividing 4 in the square root. So this is 13x minus x squared equals root x. Now we take square. 13x minus x squared equals x. Okay, equals x. Okay, this goes to x squared equals 12x. And x is positive, so the only solution is 12. X equals 12. So the radius for the largest circle is just 12. Okay. Okay, let's come to problem 13. Okay, it's a solid geometry problem. We have 6 identical balls of radius 5. They are put in a very tall cylinder with radius 8 in the compact way. Right, Lawrence pour water into the cylinder. What's the minimum volume of water he needs for all 6 balls to be completely underwater? Okay, let me draw this picture. Okay, let me try to draw the cylinder of radius 8. So the radius is 8. That means the diameter is 16. Okay, diameter is 16. And we have ball radius 5 or diameter 10. So basically, we can put one ball here like this, but we cannot put 2 balls horizontally. Okay. Okay, this is one ball of radius 5. So this is 5. This is 5. Okay. If we try to put the next ball, it will be tangent to the first ball in the following way. Okay, try to do it this way. It's slightly tilted, okay? Now let's see, this is center and this is phi. This is phi. Okay, it's tilted, so the total height will not be 20, okay? The sum of the diameter is 20, but the total height is smaller than 20 because it's tilted. Now let's try to find this height. We connect these two centers. So the actual height is this one, okay? This red one. So the distance between these two center is 10, okay? It's 10. 5 plus 5 is 10. So this distance is 5. This is 10. And on the other hand, we see that this lower, okay, this foot is 16 minus 10. Okay, 16 minus 10, because this is 5 and this is also 5. The diameter of the cylinder is 16, so this part is 6. And we see this is a right triangle, right? This is right triangle. 10, 6, so the height is 8. The height is 8. That means the vertical distance between these two centers is 8, not 10. And the total height of these two balls is going to be 5 plus 5 plus 8, which is 18. So this is like 2 times 10 minus 2. So total sum of the diameter minus 2. Minus 2. That's the total distance. Okay, now we have 6 balls. So we can keep doing this picture. This is 3, this is 4. Okay, this is like 5. This is 6. So for any two adjacent balls, the distance, the height is decreased by 2, okay? Totally we have the height. Let's call it capital H. So the sum of all the diameter is 6 times 10. But for each pair of adjacent balls, the distance, the height decreased by 2. There are 5 such pairs, so minus 5 times 2. So the actual height is basically 50. 50, okay? This height is 50. Now we pour the water into the cylinder. The volume of the water, okay, the volume of the cylinder with height 50 is equal to pi times r squared. R is 8 times the height. Height is 50. And then we minus the volumes of those balls. So they are totally 6 balls. Each ball has the volume 4 over 3 pi times r cubed. Here r is 5 cubed. And then this is the volume of the water. Okay, this is the minimum volume of the water, which equals 2,200 pi. Yeah, that will be the answer we choose B. Okay. Okay, let's do problem 14. We have 95 numbers, either 1 or minus 1, and the following sum of product is positive. We want to find the least possible value of S. All right, because we only have 2 choices, 1 or minus 1, we can assume there are K positive 1, and so 95 minus K negative 1. Okay, let's do K minus 1 and 95 minus K. Okay, let me do K plus 1, 95 minus K minus 1. And then basically we can express the value of S in terms of K. Okay, so the product is either 1 or minus 1, right? So how many 1s do we have? If the product equals 1, that means these two numbers have the same sign, either both positive 1 or both negative 1. So we have k choose 2 for all positive ones, plus 95 minus k choose 2. So these two parts contribute positive ones. And then for minus 1, that means 1 positive 1, 1 minus 1. So they are totally k times 95 minus k, such many minus 1s. And so this is the value of S. Okay, now let's expand those expressions. K choose 2, that basically is k times k minus 1 over 2. This is 95 minus k times 94 minus k over 2, and minus 95k plus k squared. Okay, so S is a function of k. Now let's try to simplify this expression by combining similar terms. So this is basically 1/2 k squared minus 1/2 k plus this is 1/2 k squared minus 189 over 2k plus 95 times 94 divided by 2 and minus 95k plus k squared. All right, we can combine the square terms. Totally, we have 2k squares. And for k terms, we have totally 190k. And for the constant term, it's just 95 times 94 divided by 2. So 95 times 47. This is the value of S. Okay. Right, now let's complete the square, because this is quadratic function of k. Let's complete the square to find the minimum value. So this is 2k squared minus 95k. I plus this term, 95 over 2 square. And then I minus 2 times 95 over 2 square. And then we add back this constant term. 95 times 47. Okay, that's function S, right? So this equals 2 times k minus 95 over 2 square. And for the constant term, it equals 95 over 2. Okay, 95 over 2. So from the problem, we know that the function S is positive. So if there's no requirement, we can basically choose k to be as close to 95 over 2 as possible. So basically we choose k equals 47. That's the minimum value of S. But this gives negative value of S. So here we consider S to be positive. That's the requirement. This is positive. So k cannot be 47. So we should choose this square such that this difference is positive. And for the later part, we know that this 95 over 2 is 47.5. Okay. So 2 times this square is larger than 47.5. So basically we need k minus 95 over 2. This square is larger than 23.75. And we know k is integer. So the smallest possible value for this parenthesis square should be 5.5 square, because 4.5 square is smaller than 23 over 23.75. So the minimum value of S is 2 times 5.5 square minus 47.5. Because k minus this 95 over 2, this must be an integer plus 1/2. Okay, so 5.5. And this equals 13. This equals 13. So 13 is the solution. That's the minimum possible value for S. Okay, this is method. Okay, now, okay, let me call this method 1. I'd like to introduce another method, which I think is better. Now let's do here. So for the second method, it's based on a formula for square of a sum. So let's record this formula. A1 plus A2 plus plus A95. The sum of these 95 terms, I take square. So this equals the square terms, A1 square plus A2 square plus 95 square. And then plus the terms with this cross product. This is basically I for all ij. Okay, I not equal to j, because if I equals j, it equals to square terms. So for I not equal to j, ai, aj, right? That's the term. And we can also write this in the following way. If we choose certain order, if we require I less than j, like in the expression of the S, 95, we have twice, okay? We have twice, because ij change order, we have twice. So you know that ai is either 1 or -1. So if we take square, it's always +1. So this is equal to 95 plus twice S, plus twice S. So we have an expression for S is A1, okay, A1 plus A2 plus A95, okay. Okay. Square minus 95 over 2. This is the function S. And we see that we need to have S positive, right? This is positive. That means this square of the parentheses is larger than 95. This is larger than 95. And because we have 95 is odd number, we have 95 terms. If we change certain okay, if some of them are positive, some of them negative, this sum is also an odd number. This is always odd number. Okay, this is odd number. And this is odd number and it's integer. This square is larger than 95. So the minimum value is 11. The minimum value is 11. Of course, if it's positive, the minimum value is 10, right? 10 square is 100 larger than 95. But here, because we have 95 terms, this term must be positive, or not must be odd number. So the minimum value is not 10 square minus 95, but 11 square minus 95 over 2. So this is 121 minus 95 over 2. This is 26 over 2, which is 13. So the answer is 13. Okay, you can choose the one you prefer to solve the problem. Okay, yeah, that's the problem. That's the solution.